Okay, so number 5, we have a train that leaves a station. I'm gonna draw this as a car because I can't draw very well. So always start with a diagram. Doing a diagram is going to help you a lot. So here's a car, leaves the station at the 1,200 meter marker. So like right here, if you look out of the car on the ground, you're going to see on the ground what? 1,200 meters. In fact, you see these on highways. You ever notice on highways they have like different markers? I think the highway patrol uses them. So right here is the 1,200 meter marker, traveling with a constant speed of 42 meter per second. So I'm just going to label that as velocity. Speed and velocity are oftentimes interchangeable. The only time they'd be different is if the object changes direction. So we'll just label that as v, 42 meter per second. And the question is, how many seconds later will the train pass the 1620 meter marker? So down the road here is 1,620 meters. So look, what is the displacement, the delta x? What's the displacement from 1,200 to 1620? 420. And that's what matters, right? That's what matters. Because when we define velocity, the definition for velocity is displacement over time. Okay, so taking this equation, taking our definition for velocity and rearranging it with algebra, we're looking for time, right? The question says, how many seconds later will the train pass the 1620 marker? So taking this equation, solving for time, we get what? Time will be what? Delta x over v. So that's algebra there. Like if you're having trouble doing that, one way to think about it, like so here we have v over 1 equals delta x over t. So for starters, you could flip both sides. You could say 1 over v equals delta t over delta x. Then what do? Multiply both sides by delta x, and the delta x cancels. So you get delta t equals delta x over v. Okay, so the delta x is 420. The velocity is 42 meters per second. So the meters cancel, and you end up with 10 seconds. Okay? Okay, B. What's the velocity of the train in kilometers per hour? So what type of problem is this? Conversion. You just got to convert. So I'll do the first one. So the first one, Roman numeral I, we're going to go 42 meters per second, and we're going to convert this to kilometers per hour. So this is a conversion. So we put meter on the bottom, kilometer up top, and then the conversion there is 1 kilometer is 1,000 meters. So meters cancel. And now we put seconds up there to cancel the second, and then hour in the bottom. And there's not 60 seconds in an hour. A lot of kids made that there. How many seconds are in an hour? 3,600. 60 times 60. Okay, then the seconds cancel, and then the conversion comes out as 151.2. Don't worry about sig figs anymore.
So would that be a multiple choice question?
Well, for the most part, the quizzes will be multiple choice, and then the midterm will be free response. The midterm exam, which is going to be, once we've gotten enough physics under our belt, we'll do a free response, cumulative physics exam. And you can drop your 2 lowest quizzes. You can't drop the midterm, but the midterm is not going to be for a while. You don't have to worry about the midterm yet.
So the midterm is worth more points than the quiz.
Well, the quizzes are 20% of your grade. The midterm's 20% of your grade. So basically, the midterm exam is equal to all the quizzes we take the whole semester. So quizzes are kind of lower stress, and then the midterm, you gotta, with the midterm, I grade it by hand, you get partial credit. I'm gonna give you a practice test, I curve it. Kids, for the most part, do pretty well on the midterm.
How many quizzes can you have?
2. You can drop,
And it's this semester.
I drop 1 at the quarter, and then the other 1 at the semester.
Is there a midterm? Is there a quarterfinal?
I guess I never recorded. Oh well.
You can still save
Yeah. Oh well. I guess that one is not making it to my website. Okay. Should we do a hard one?
do it. Yes.
Okay, this one is challenging. Okay, let's record this.